Okay guys, so in this video I'll discuss the problem iron magnet and wall. It's a Codechef problem of November challenge. So let's see what the question has to say so that we can find clues from this question which will help us in solving and formulating the idea so that we can solve this problem. We are given a string and the string contains 5 characters I am underscore and this character, and there is a cross. Each character has its own meaning, which is listed here, that is I for iron, M for magnet, and so on. Magnet has a power of K, and its power decreases if you go either left or right, and this is the formula for the power of the magnet if we'll go either left or right in the array. This will be used when we'll try to find the solution. So the question is about we have to maximize the count of the magnet which will attract an iron. The condition is that each magnet can attract only one iron. Few other conditions in this question are the magnet will attract only those irons where its power is greater than 0, and the power of the magnet will be equal to 0 when it will encounter a cross character. That is, if there is a cross character between a magnet and the iron in between them, then the magnet cannot attract that iron because its power will not be greater than 0. It's very simple. So this is the logic, this is the question, and now I think we should move on to how we can solve this problem. So coming to its solution, if you notice, we have to count the maximum pair of magnet and iron. That is, we have to make pairs of iron and magnet. So this also means that our answer cannot be greater than minimum count of magnet and iron. For example, if you have 2 magnets and 3 irons, we can only make 2 pairs, and this will be helpful in reducing our search area. Now I have mentioned the second point. First, search an iron to left of a magnet going from left to right. For example, if you are going in the string as given here from left to right and you found the first magnet, then you should search the iron to its left, because we have to assign iron to the first magnet. And why I should do so? Because the iron which is present in the left of a magnet can only be used by the leftmost magnet, and if you are going from left to right, the first magnet you will see will be leftmost magnet, and the leftmost iron can only be assigned to this magnet. So this way we can maximize our result. So, and this can also be done in O of K, that is the power of the magnet. So this is the second point I have mentioned here. On contrary to the second point which I have just said, consider the case if I assign the first left iron found to left of a magnet. For example, in this case, if the power is equal to 4, then this magnet can attract this magnet iron as well as this iron. And what if I assign this iron to the first magnet? Then for the next magnet there will be no iron left, because this iron can only attract this iron, but this magnet can attract both of these irons. This means that the leftmost iron should be given to the first magnet, and this will maximize our result. In this case, if K is equal to 4, the answer will be 2. Now coming to the last point, assign first iron found to right of a magnet. This means that if you do not find iron to left of a magnet in its power range, then you will go for a right search, and in this case, unlike the left search, you will assign the first iron found to right of a magnet. I will explain this case with this example. In this example we have two magnets and two iron, and we are going from left to right search. We first saw a magnet and we didn't find any iron to its left, so we are going to right search. Unlike left search, in right search we will assign the first iron found to right of a magnet. In left search we were looking for the leftmost iron found to the left of the magnet, but in right search we will assign the first iron found to the right of a magnet. And why so? Let me explain this case. We have two magnets and two irons, and consider a case of k equal to 4. So if you see, the left magnet can reach to both of the irons, but for the right magnet it can only reach up to this iron, that is the middle one. You can see for k equal to 4, 1, 2, 3, 4. This means that its power will decrease after 4 cell, and at 4 cell it will have power 1, so it will reach up to both of the magnet for the left one. What if we assign the second iron to the left magnet? Then the right magnet has no iron to attract, and that's why in right search we are assigning the first iron found to the right of a magnet. So these are all the points which we have analyzed. We have to implement these points in our answer, and let's see in what order we have to implement this. So I'm taking this example once again. I will go for search of a magnet first from left to right, and if I find a magnet then I'll go for a left search, and if I find an iron for that magnet in left search in its power range, then I will terminate the search and move on for next magnet. And if I didn't find the magnet iron in left search, then I will go for a right search, and if I find an iron in right search, then I will terminate the search and move on. And even if I didn't find the iron in right search, then also I would have to terminate the search and I will go for the next search of magnet. So this is all about the solution of this problem, but there is a problem, and this solution is going to be O of n square, because k is equal to n, that is 10 power 5, and n will be also 10 power 5. So this solution is technically going to be O of n square. Now you have to reduce our search area, as I have said, and if you notice, your count will be less than minimum of count of magnet and count of iron. We mentioned this in our first point, which is to count the maximum pair of magnet and iron. So your pair will be less than the minimum of count of magnet and count of iron. So when your count reaches to this number, we don't need to go for any further search of magnet or iron. So this thing is going to reduce our search area. I missed one point to say. If you assign an iron to a magnet, then you will place a dummy character at the place of that iron, so that it will not be used further. So this is all about the solution. You can get the code for this solution in the description. I hope you would have got some idea how to solve this problem. And one more thing, if you like the video, please hit the like button. If you dislike the video, please hit the dislike button. But in both the cases, please subscribe to my channel. I am new on this platform. Thanks for watching.